Yeah, let's start.
Okay. Okay, sir. Thank you. So good evening, and let's start. Let's start today's discussion on maths, engineering, mathematics questions that were asked in CS Computer Science Gate exam. Uh, this this Gate exam 2024 paper. But before starting the discussion, uh, you can circulate this information about the various courses offered by the IIT's GATE classes. Uh, One can have online coaching, targeted GATE course, test series, as well as distance learning program. And there are various streams for which you can avail these services, which includes aerospace, mechanical, EC, EE, CS, DA, etc. And if you are interested to do well in competitive exams such as GATE and many other state level exams, also technical exams, if you want to do well in them, you can look forward and explore these options. So, first, we will. Yeah, so as I said, this is GATE 2024 Computer Science and Information Technology paper discussion, and particularly engineering mathematics question from them. There were two sets of paper. One was in the morning, one was in the afternoon. So set one, we'll discuss first about the set one, and then we'll go to the set two. Some of interesting questions from each set, and we'll try to analyze how to solve these type of questions and what can be done if similar questions are asked in other gate exam or other exams also. And this is since mathematics is ubiquitous, there is a high chance that you'll see similar questions in other exams also. So there were around total five questions in set one, and each like four of them were having 1 mark, and one was 2 marks question. So total you could have scored 8 marks only from mathematics background in set one only. So let's go ahead and start our discussion about the questions that were asked in set one. So first is question number 11, and it is mentioned that let f be a function which maps from R to R. So it's a real valued function. It takes real values as input and gives out the real values, such that f of x is uh, having this form. So what does that mean? That means f of x, which is a function, is defined as this max represents maximum. So maximum of x comma x cube, and x can take any value between the real domain or real number. So here it is mentioned that where R is the set of all real numbers. Then in the question it is asked that set of all points where f of x is not differentiable. So this is these last two words which I just highlighted. Uh, that is the crux of the question. So they are asking find those points for this function where this function is not differentiable. They are not saying anything about continuity or anything about that or maxima minima here. It's just straightforward differentiable or not question. And there are four options, and if you don't know, this represents a set of numbers. So uh, all options have certain set of number. That means we need to check at these points for x values of these points whether this f of x is differentiable or not. So let's go ahead and first of all let's look at our function. 1 second. Yeah. So f of x is uh, given as max of x comma x cube. So if you want to see, there are two ways to do to solve this question. One is graphical method, as well as another is typical, using the definition of left hand side derivative and right hand side derivative at a point. If those derivatives are equal, then only the function is differentiable. If they are not, that means it's not differentiable. So you can do it both ways. We'll do it in both ways also. But the easiest way, or I think the intuitive way, is, I feel, is graphical method. One second. Yeah, so let's say this is our x-axis and this is our y-axis, and we all know that y equal to x represent a line which is uh, having slope of 1 or 45 degrees. So this is your line which represents y equal to x, assuming this is your x-axis and this is your y-axis, which is a standard convention that will follow here. And then there is another function which is y equal to x cube. So uh, these two functions intersect at +1 and -1. How do I know it? Uh, if I can just equate these two. So I want to know where these two functions intersect. So you can see it will be x into x square minus 1 equal to 0, and that gives you values where x is 0 or 1 or -1. So there are 3 points at which these functions intersect. And if you see, this is your origin, and then let's say if this is your +1, x equal to +1, and this will be your x equal to -1. So here these functions which are given by y equal to x and y equal to x cube, they will intersect, right? And if you know the nature, you can take, see, if you know, then it's good. If you don't, you can just take some values of x, and you can see that between 0 to 1 for x value, y equal to x is greater than y equal to x cube, because when x is less than 1, its powers are even lesser than 1, lesser than x. And same thing happens on the negative side of the graph. Here also it looks something like this. And so yeah, so this is your typical graphical representation of this curve. Maybe I can use some dashed lines to highlight that these intersect at +1 and -1 as well as 0. But in the question, maybe I'll use a different color here. In the question, the keyword is
You are currently the only person in this conference.
Akshay, your voice is gone.
Okay, so apparently there was some internet issue.
Yeah, now you are audible. Please explain.
Yeah, so basically you plot the function. This is a graphical method, and you can see here at these 3 points. So this third point will be your x is -1 and y is also -1. So at these 3 points, your function has sharp edge or sharp turn or bend, and therefore the slopes at those points will not be equal, and therefore the function is not differentiable at these points. So and in this question, in options, they are only asking about x values. So the correct answer will be the option with x value of -1, 0 and 1. So this will be your correct option, and that is option number D. So this is how you do it using graphical method. What if somebody doesn't know graphical method? That is fine. You can use the classical definition of differentiability. Now you know these two curves intersect at -1, 0 and 1. So uh, in between those points, the function is continuous. So you can't say it is not differentiable, because whether it's y equal to x, whether it's y equal to x or y equal to x cube, these functions on their alone, standalone, they are differentiable. So you have to check only where they are intersecting. So let's say at 1 second. Sorry. Hmm. So first we'll check at x equal to 0. Then, or even before that, we can just write your f of x and its derivative. So that will help you in visualizing everything together. And how we do that? See, your f of x now has uh, a nature which is divided into 4 parts. So it is x when x is less than -1. It is x cube when it is -1 and 0. It is x in the region 0 to 1, and it is again x cube in the region x greater than or equal to 1. One may argue that why am I putting equality sign in, let's say, here y is it equal to 0 and here it's not. It doesn't matter, you can change it anyway. So your answer should not change. You can try that if anybody has that doubt. And then what you do, you take the differentiation of your function. So the domain or the region of the function remains same. So here the derivative is 1, because derivative of x is 1. Then it becomes 3x square in the region -1 to 0. Then again it becomes 1 in the region 0 to 1. And it again goes to 3x square for x values greater than or equal to 1. So now you know the nature of your f dash of x. So then you can just see at what points these this function is not differentiable, and that is you can just check. Let's say, for example, we can check for at x equal to -1. What is your left hand derivative? Left hand derivative represents you're approaching the number line from left side, so from minus 1.5 to 1, let's say that direction you're approaching. So you'll take the left hand derivative as 1 because it's constant there. And what is right hand derivative? It is 3x square, right? And x is equal to -1. So this gives you 3. So since uh, right hand derivative is not equal to left hand derivative, f of x is not differentiable at x equal to -1. And similarly, you can check for x equal to 0. From here itself, you'll see when you put x equal to 0, left hand derivative becomes 0 and right hand derivative is 1. So again, it's not differentiable. And at x equal to 1, left hand derivative is 1 and right hand derivative is 3. So there also it's not differentiable. So there are 3 points at which this function is not differentiable. And those points are -1, 0 and 1. And that is actually, I think, option D. Yeah, so option D is the correct option. Okay, so I hope you understood how to use graphical method as well as the classical definition of differentiability of a function. So then we'll go to the next question, which is question number 12. And in this question, it was asked that what is the product of all eigenvalues? And this is 3 by 3 matrix, which is given like this. So, typically what I have seen in GATE exam is there will be one question on limits, and typically there will be one question of eigenvalues of matrix. So the type of question may change, but this type of typical questions are frequently asked. So now, as we all know, first of all, the product of the eigenvalues, product of eigenvalues is nothing but determinant of the matrix. So let's say if I call this matrix as A matrix, so product of eigenvalues of matrix A will be nothing but equal to the determinant of matrix A. So there are 4 options here. So first we need to find the determinant of matrix A. So let's say I will write the matrix A separately here. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 3 cross 3 matrix. It's a square matrix, so its determinant is defined. If it's a non-square matrix, you can't even determine its determinant. So now, what is the determinant? Classical definition of determinant: 1 in bracket 5 into 9, 45 minus 48. Then the second column and minor of that column, so that will be 36 minus 42, and the last term will be 3 into 32 minus 35. So if you further simplify, this becomes minus 3. This is minus 6 into minus 2, that will be plus 12. And this will be minus 3 into 3, that will be minus 9. So the determinant is 0. And therefore, the product of eigenvalues is 0. So option B is the correct option. And there is another way to solve these type of questions. It's basically to check whether any 2 rows or any 2 columns are dependent on each other. If they are, then by matrix property, if any row or any column is dependent or scaled values of other column or row, then the determinant becomes 0 because the rank is less than the number of rows or number of columns. That is the property of matrix. So that also you can do. You can check how. Let's say again we'll write our matrix 4, 5, 6, 7, 8, 9. So now if you do a elementary transformation, which is R2 changes to R2 minus 1. So basically you subtract R1, which is row 1, from second row, and at the same time you subtract R3 minus 2R1. So basically you subtract 2 times, you multiply row 1 by 2 times, and then subtract that 2 into R1 from the third row. And if you do that, what happens? Your A matrix, it's not equal, but this is its, some form. So the first row remains as it is because there is no change to it. And let's say R2 minus R1. So 4 minus 1, this becomes 3. This becomes 3. And this becomes 3. And from R3, if you subtract 2 times of R1, are not needed to actually. It's like you can just simply subtract single times. Then this becomes 6, 6, and 6. So now you see in this form, your R3 is nothing but 2 times of R1. So rank of your matrix A is 2 less than 3, and that it itself gives you that your determinant of A will be 0. So this way also you can check. So whatever way you want to do, you can do. But the correct answer is determinant of A is 0, therefore product is 0. So option B is correct. Okay, so let's move on to next question. Yeah, so this was a question. Prima facie it looks slightly scary because there is, first of all, it's a lengthy question, and the options are also not that easy by the looks of it. But if you just read through it and carefully if you observe, this is question number 14, and what it says is, consider a permutation sampled uniformly. So it's a permutation and it is a uniform sampling. So there is no bias when you do the permutation. So any permutation can turn up with equal probability at random from set of all permutations of, so there is a set of numbers which is 1 2 3 up to n, and then n has to be greater than or equal to 4. So n cannot be 3, n can be 4 5 and above that. Let x be the event that, so there is an event x that represents that 1 occurs before 2 in the permutation. So let's say, okay, let's first read the question. So x represents the event that highlights when 1 occurs before 2, and y is the event that in which 3 occurs before 4. So these two events are defined like this. So which one of the following statement is true? So here important keyword is 1. So there is only one option that is correct. It's not a multiple choice type of question. So then what should you do is, before solving the question, at least try to understand it. What does it mean? And the simplest way is, if you don't know this much, or if you are not confident in the probability or statistics part, what you can do, since they have mentioned that n cannot be greater than n cannot be smaller than 4. So n can be 4, right? So n can take value 4, and if that is there, the number of numbers available for various permutations are 4 numbers, 1 2 3 4. So now let's say we need to see what is x, what is the x event. So x is the event in which, one second, event in which 1 occurs before 4. So here 1 occurs before 4. Okay, so let's say if you pick 4 numbers, you cannot repeat them here because they are, it's not mentioned that, and they are like natural numbers. So what is the, let's say there are, like, we'll mention some permutations which can be part of this x event. So if one has to occur before 2, so number can be something like this. So 1 2 3 4 can be part of x, as well as 1 2 4 3 can also be part of x. So like that you can identify other cases also. So other cases will comprise of something like this and something like this. So there will be uh, two combinations here, two here, two here. So there will be total 6 combinations, right? Similarly, y is the event where 3 occurs. So I'm sorry, it is 1 occurs before 2 here, and in y it is 3 occurs before 4. That is the definition of these two events. And then again you can see, right, so let's say if this is the end of it. So 3 has to occur before 4, right? So one option could be this, another option could be something like this, 3 4, and one more option could be something like this. So you can fill 1 and 2 in the empty spaces, right? So there are 2 ways here, 2 ways here, 2 ways here. So total 6 ways are here also, right? To fill the 1 2 in the empty slots. And then there are some examples of permutations which can be part of event x are 3 1 4 3 4 1 2 3 4 2 1. So like that, total 6 will be there. So now you understood, right, what is the definition of x and y. Now you can solve these questions. Not a big deal now, because once you understand what it says, uh, then you can go. So better is to check option wise. So first option says the events X and Y are mutually exclusive. So X and Y are mutually exclusive. So this is the claim that option A makes. Now we have to check whether it's correct or false. So uh, what do you mean by mutually exclusive? That is the key question here. So that means whether it is possible to have both, uh, 1 before 2 and 3 before 4. So mutually exclusive means, so the question that you need to ask yourself is that whether, one second, whether, or I'll just say F because if it is possible to have both events happening together. So that means, is there any permutation where uh, you know X event happens that represents 1 before 2 as well as Y event that represents 3 before 4? So is there any permutation combination like this? And there is, right? So if I get a permutation like this, so we'll continue our case where n is 4 because that's easy to visualize. So there is a possibility where you will have this permutation where 1 2 3 4 is there. So the X event is also there and Y event is also there, right? So therefore these X and Y are not X and Y, sorry. Therefore X and Y are not mutually exclusive, and therefore this option is not right. I hope you got the point. Because there exists a permutation in which both events are true, so they cannot be mutually exclusive. Now option B says events X and Y are independent. So we need to check whether X and Y are independent. So now again the question that you need to answer is, what do you mean by independence of the events? So what I mean by independence is, whether or not X has happened. So basically, like probability of X happening or not happening does not affect, uh, in any way the probability of Y happening or not. So uh, what I mean is, independence definition, and that is the definition for, common definition for two events. If they are independent, that means the probability or the event space of second event does not depend on the occurrence of first event. They have no dependence on each other. So what it means is no dependence between occurrence of X and Y. And it is true, right? Because X is defined as 1 before 2 and Y is defined as 3 before 4. And this is a uniformly sampled permutations. So there is no dependence of X and Y on each other. Therefore, by definition, X and Y are independent. Because there is no case or no permutation where uh, you know the there is any bearing of happening of X or not happening of X on the event of Y. So they are clearly independent. So this is the correct option. Now one can stop at this option, but you know uh, what you say, uh, it is always a good practice to check all the options even if you find the correct answer, because in exams you may make a mistake and let's say by mistake you arrive at the conclusion that option B is correct, and if you even don't check option C and D, then it's a negligence on your part. So it's better to just confirm whether C and D are not correct also. So we'll do that. One second. Yeah, so let's see option number C, third option. It says that these X and Y, either X or Y must occur. So uh, it says that either X should happen or Y should happen. So what it means is either 1 before 2 or 3 before 4 must happen. So is there any case where this doesn't happen? And that is there, right? So if you take permutation something like this, 2 1 4 3. So here event X is not happening, as well as event Y is also not happening, and it is a valid permutation, right? So therefore this option is also wrong, because I just presented you a case where X is also not happening and Y is also not happening, still you have a valid permutation. So therefore option C is also not correct. And option D, okay, we'll see here only. So option D says either X is more like event X is more likely than Y. So basically what it says is probability of X happening is greater than probability of Y happening. Now this can be tricky, but since we are going with n equal to 4, that's actually a good and simplest way to solve this problem without getting confused in exam. So now, as I said earlier, so there are 6 ways for Y to happen, and there are 6 ways for X to happen, right? And which are listed here. And what is the total number of permutations that are possible? So if you have 4 spaces, and if you want to fill the numbers without repetition, so that will be, you can fill by 4, then you can fill only 3, and then 2 and 1. So basically 4 factorial. So that is your total probability. So total sample space, number of samples. Then what is your probability of X? So X can have 6 elements, and 4 factorial is nothing but 24, right? Similarly, Y will have 6 combinations or permutations that will satisfy the definition of Y, and divided by your total number of permutations possible. So you can see the probabilities are same. So it's not like one will have more likelihood and other will have less. So therefore the option D is also incorrect. And this is how you need to solve this type of question. Assume the simplest case and then check each option. Even if you find option A as the correct answer, don't stop there. Just to make sure that you are not overconfident or not doing any silly mistake, check all the options and then proceed to the next question. So now next question is question number 27, and it says that let A and B be 2 events. So there are 2 events in probability space where probability of A is 0.3 and probability of B is 0.5, and probability of A intersection B is 0.1. So A intersection B represents the uh, you know the 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 elements of A and B which are common to each other. Then which of the following statement is R or true? So that is important. So now this is a multiple choice question. It can be or cannot be. See, the trickiest question that I think there in any competitive exam is when they say it is a multiple option correct and only one option is correct. So that is the most trickiest question is what I feel. So now first option is we have to check the independence of A and B. So let's note down what is given to us. In this question, it is given that probability of A is, I think, 0.3. Yeah. Probability of B is 0.5. And probability of A intersection B is 0.1. So option A says we have to check whether A and B are independent. So we know that A and B are independent if when do you say two sets are independent? When their individual probability multiplication is equal to the probability of their intersection, right? That is the definition of independence. Am I right? Yeah. So by that logic, you need to check whether your P of A into P of B is equal to P of A intersection B or not. Let me just 1 second. Just hold on.
I think
Hello. Yeah, I think the recording is on. Yeah. So when two sets are independent, if as I said, their intersection probability is equal to their product of their individual probabilities. So what is this? In our case, it is 0.1. And what is this side? It is 0.3 into 0.5. So that is 0.15. So since they are not equal, that means therefore A and B are not independent, right? So that is the first. So first option is not true. Now let's see the second option. 1 second. My voice is gone again. Okay. Yeah, so here it shows that I am having my audio. Uh, yeah, I think audio is there. So the first option is not correct. Let's see the second option, where the second option asks us to find out the probability of A union B. So we know that by
Akshay, there were some extra sounds were coming.
no, I think, sir, I was flipping my notebook, so that's why maybe that paper sound was there. Actually, it fell down. So I think now is it coming?
No, now it's okay. Please.
Okay. Yeah.
Yeah,
So
thank you.
in the second option, by addition rule of probabilities, we know that probability of A union B is nothing but probability of A plus B minus probability of A intersection B. So all these values are directly given in the question, so you can just put them. 0.3 plus 0.5 minus 0.1. So it is 0.7. But in the question, in option B, it is given as 0.7. So option B is correct. Now we can check option C. It says that what is the probability of A intersection B complement. So sometimes they write it as B bar. I'll choose B bar because it is easy. Otherwise, sometimes people get confused between superscript and usual normal script. So here, if you don't remember the formula, you can draw a Venn diagram just to clarify yourself. So these will be the space, the total sample space, and circles represent A and B. So now, what happens? What is B complement? B complement is the total area shown by this red lines, which is part of your total sample space, but it is not the part of your set B. So the red dashes represent B complement, right? And now, what else is there? Now you need to find out intersection between A and B complement. So what is the intersection between A and B complement? This is the area represented by uh, green lines that I'm drawing right now. So these green lines, they represent your A intersection B complement. Correct, no? So, in other words, what is this A intersection B transpose B complement is nothing but it is just you subtract from total A probability of A, you subtract their intersection. So you will get the same value, right? You can confirm that with this diagram, Venn diagram. And why did I choose PA and P intersection B? Because those are known values in the question. So PA is 0.3 and PAB is 0.1. That gives you 0.2. And that is also correct because in question in C option they have given it as 0.2. So C also is correct. Now option D, where it is asked that in option D they are asking about probability of A complement intersecting with probability of B complement. So there is a direct formula that one can use, that is it is nothing but total probability minus A union B. And now how do you come up with that? You can again take the help of Venn diagram here. Venn diagram is very handy tool when it comes to solving these type of questions, because if you don't remember the formula, you can just draw the Venn diagrams and you can just check. So now what is A complement? A complement is anything other than A in your total space. So these red lines represent A complement, right? A complement will include B also because that is part which is not in A by definition. So your red lines, they represent your A complement. And let's say we'll use some other color, let's say green, to highlight B complement. And B complement will be anything other than B, right? So B complement will be this part. Right. So this is your B complement. Now you can observe one thing, that what is the area, that is intersection of these two red and green lines. So you can see this is the area which I am again highlighting it, the total sample space and this area. So you remove A and B completely from the sample space and you will get the area which is intersection of A complement and B complement, and that is what is represented by 1 minus probability of A union B. I hope that is clear now. So now we calculated A union B, right, in the option B, that was 0.7. So this becomes 0.3 and it is not equal to 0.4 which was given in option D. So if you go back and check the options, option D says it is equal to 0.4 but it's equal to 0.3. So A and D are not correct, B and C are correct. So that is the solution. Yeah, so now this is the most important question of this discussion, today's discussion, because prima facie, or like if you read the question first time, you'll think that it's very simple question, but it's, I think, the trickiest question in the amongst the all problems that we'll discuss today. So it is question number 49 of set 1, and it says let A be n cross m matrix where m is greater than n. So what does m greater than n mean? That means your so it is n cross m. So your columns are greater than rows. We have a matrix which is not a square matrix now, it is a rectangular matrix, and where your columns are greater than your rows. Number of columns is greater than number of rows. So for such matrix, which of the following statement is or are? So this is also a tricky part. It is a multiple choice question. And we need to find which are true. For a system of linear equation where ax equal to b, ax equal to 0. So that represents a null space of a matrix A. So the definition of null space is you need to find you need to find Ax equal to 0, and the values of x that satisfies Ax equal to 0, that characterizes the null space of matrix A. So now this is the information that is given, and now we have to check four options, and there are multiple options correct. So let's see. First option says that there exist at least m minus 1 linearly independent solutions to this system. So okay, so for this thing, see, there is a way to solve this. Okay, because if you don't know the theorems of matrices, etc., or if you don't remember them in the exam, you can take multiple examples of matrix A and then you can solve. What I mean by that is, you can consider matrix A, which will be something like, it will have only one row and four columns, because in this case your columns are greater than your number of rows, right? So you can take this type of matrix, or one can take a matrix where there are two rows and four columns, or two rows and five columns, anything like that. And for these type of cases, you can check whether any of the case violates the option. If it does, that means that option is not true for all cases, and you can just cross check it and go to the next option. What I mean by that, that A can be something like A001, something like one row, four columns, or A can be 10010100. For the sake of simplicity, you can just take 10, because then your calculations will be easy. That is one way to do this. And if not, then you should know there is something called as nullity theorem. Rank, what do you call, rank nullity theorem. So what it means is, and that is relevant for your option number A. So it's a very famous theorem. What it means is, in this case, rank of your matrix A, let's say that is your matrix, plus nullity of that matrix will be equal to what do you say, equal to m. M is your number of what is m here, columns. So this is a theorem, so there will be a proof to it, but we will not discuss that today. It is out of the scope of this discussion. So rank of A plus nullity of A, if you, and nullity of A essentially represents x values where Ax equal to 0. That's why we are dealing with nullity here. And m is number of columns. Here m is greater than n, right? So that is one thing. Now the question that you need to ask yourself is, what can be the rank of matrix A? So let's say consider this example of rank or matrix A, which has two rows and let's say four columns. So at the max, rank of A can only be equal to one second. Rank of A can be equal to 2 or 1, right? Because if both the rows are linearly dependent on each other, then your rank will become 1. And if they are not, if they are linearly independent, then the rank is 2. So basically your rank will be always less than or equal to your number of rows. If all rows are linearly independent, it will be equal to n. Otherwise, it will be equal to it will be lesser than n, and it will depend on how many rows are dependent on each other. So if you do that, so now uh, you know uh, you can use this inequality. And what I mean by that is, let's say we represent this nullity by a symbol something like capital N of A. Then what you have here is capital of N of A, that means nullity of A, minus M, or you can do the other way also. One second.
You are currently the only person in this conference.
Yeah, so What I mean by that is, this m minus na, capital Na, sorry. So if you take this capital Na to the RHS, that will become m minus Na, and this can be equal to n or less than n. So you have something like this inequality, and therefore your m minus n can be equal to n of a. So your nullity will be either equal to m minus n or it will be greater than that, and that is what first option says. So if you read first option, it says there exist at least m minus n linearly independent solutions to this system. And see, basically it is ax equal to 0 system, right? So its independent or solutions to this system will be nothing but your nullity. And option A says at least m minus n, and that is true, right? We obtained using rank nullity theorem here, and therefore option A is correct. So there will be some m minus n linearly independent solutions to this system. And what I mean by that is, let's say we'll take this example of matrix A, and what happens here, if rank is equal to 1, then your nullity will be 4 minus 1, that will give you 3. But if rank is 2, then your nullity will be 4 minus 2, it will be 2. So it cannot be less than 2, it can be greater than 2, and that is what this first option says, and that's why it's correct. So now let's go to the second option. Second option says there exist m minus n linearly independent vectors such that every solution is a linear combination of these vectors. So this is also again a quite heavy, technically heavy statement. So we know that there can be at least m minus 1 linearly independent solutions. So let's assume that there are m minus 1. So there will be one case where your rank of your matrix will be equal to n, which is number of rows, and in that case you will have exactly m minus n linearly independent solutions to ax equal to 0, which is your system. And in that case, we know that if you have some, let's say m minus n is, let's say, 4. So we know that by definition of linearly independent vectors, we can use these vectors and form a basis, and we can use it as a subspace. We discussed in the DA class also this part, and they will 0 0 is the solution of this system always, because when you put x equal to all 0 elements, you obviously get the solution. So this vector space will be satisfying all the properties of additivity, scalability, and zero inclusion, and therefore we can have a linearly independent vector, and they can represent linear combination, and all solutions can be represented using them because they are linearly independent. So that is true. So one can represent every solution can be represented by these vectors because they are linearly independent and they form a vector space or subspace, you can say. But there is a case, second case, when your rank of your matrix A is less than n, and that happens when, let's say, any two rows are linearly dependent on each other of matrix A. So in that case, what happens? I'll just give you one example. Let's say m we take 5 and n we take 2. So this m minus n becomes 3. So that means you have a matrix which has 2 rows and 5 columns, and then there will be 3 linearly independent vectors if your rank of matrix is 2. But what if your rank of matrix A is 1? In that case, what happens? Your m will still be 5, n becomes 1, and your m minus n becomes 4, right? So now the problem here is you cannot represent. So there are like 4 vectors, right, which are linearly independent to each other, and you cannot represent fourth vector as a linear combination of other 3 vectors. So what I mean is, maybe I'll write it down. One cannot express fourth vector, which is also a solution. So this X matrix will have, 4 independent. It will be comprising of 4 independent solutions, and you cannot express fourth vector, which is also a solution, by linear by linear combination of other 3 vectors. That is not possible because these 4 vectors are linearly independent of each other. So you cannot express fourth vector as a linear combination of other 3 vectors, because that's a fourth dimension altogether. That is not in this dimension spanned by these 3 other vectors. So this is the case where this sentence fails. The sentence holds true when your rank is equal to your number of rows, but if your rank is less than number of rows, option B fails. Uh, uh, you can do one exercise. Maybe you can take matrix something like this: 1 0 0 1 0 0 1 1 0, something like this. So this is a 2 cross 5 matrix, and you can do this because here your rank. Yeah, so here your rank will be 2, and then you can see you'll get 3 independent vectors for solution of x equal to 0, and then it is fine. But let's say if this situation changes,
You are currently the only person in this conference.
so let's say this row becomes something like 2 0 0 0 2. So in this case, your rank of matrix will be 1 because row 2 is dependent on row 1. And in this case, you will realize that you will have 4 linearly independent solutions, and you cannot express fourth linearly independent solution as the combination of other 3 solutions. So that is where this fails. It's a very tricky part actually, because most of the time what people think, if option A is correct, second will also be correct, but it is not. It fails in case where your rank is basically your matrix A is not a full rank matrix. So now option C, which says there exists a non-zero solution in which at least m minus n variables are 0. So here you cannot use like theorems and all. What you have to do is, uh, you have to be smart about this. So okay, let's say again we'll go with some examples so that things become easy. So your option C is, what it says is there exists a non-zero solution in which at least m minus n variables are 0. So let's say we take m again as m is your columns, right? Yeah, so m, let's say 5, n equal to 2, and then it says that there is a solution in which at least m minus n variables are 0. So m minus n is equal to 5 minus 2, so 3. So it says that there will be a solution. So since it's a 5 column 5 column 2 rows matrix, we will have solution something which will have x1 x2 x3 x4 and x5. So basically your solution will be 5 rows into 1 column, and it is saying that out of these 5 x's, at least 3 will be 0. So uh, you know here also again there are 2 cases. Case 1, uh, so case 1, when your rank of matrix A is equal to n, so it is a full rank matrix. So in this case, if it is 2, so let's say again 1 0 0 0 1, and let's say 0 1 0 0 1, something like this. So this is linearly independent, so rank is 2 for this matrix. And if you solve this, and what happens here is you get solution of the form which is x1 plus x5 is equal to 0, and x2 plus x4 is equal to 0. X3 is always 0. So here what it is saying is, so here x1 is minus x5 and x2 will be minus x4. So basically your solution will look something like this. So if you just put x1 as here, so x5 is also x1, so it will be like this. x2 if you keep, this will be minus x2, and this is always 0. So this is one case. You can take any other easy case also. There is no point there, no problem there. So what this option is saying, that there should be at least 3 variables that has to be 0. And now you tell me, in this case, if I put 3 variables 0, see x3 is always 0. So other 3 variables are x1 and x2. So if I make them 0, this whole thing will become 0, right? All elements will become 0. And that is not a non-zero solution. So therefore, your C option is also not always correct. So you have to check. See, what I'm telling here is a condensed solution. But when I was solving, I also took a lot of permutation combinations, and then I arrived at this conclusion that this option is also wrong. Now the last option, which is option number, option D. This is also thoda tricky. What it says is, there exists a solution in which, one second, I'll just read out it loud. So option D says there exists a solution. So when they mean solution, it is typically a non-zero solution in which at least n variables are non-zero. So this is option 4. So let's say again we'll continue with the same. M is 5, N is 2. So it says for such or even in this case, so you can even assume single row matrix. That will be even easy. What you do, you assume m equal to 4 and n equal to 1. So it's some matrix which is a single row matrix, and it will have some entries like this. So this is 1 cross 4, right? So it says n variable 0. So in which at least n variables are 0. Okay. So at least n variable 0. So here n is 1. So at least one variable 0. Here the solution will be x1 plus x3 will be 0. So if x3 is 0, x1 is 0. So again, this also is not correct, no? So this case fails the option D, because if one of them is 0, or maybe x2 and x4 are 0, so you can argue there. But let's say I change the matrix, and if I make it something like this, this is the case where it fails. And that is what you need to find out. Let's say we have a matrix which is 1 0 0 0. So here you have a solution which is x equal to k, and k can take infinite values. So if you make x1 also 0, then the whole solution goes to 0 solution. That is a trivial solution. So there also this option fails. So only option A is correct. So this is the trickiest question that I thought is there. You can again go back to the explanation and see. But the idea is to find such a matrix which violates this option, any of this option. If you find such matrix, then that option is wrong. So let's move on to the next questions. Yeah, so this is actually a question where they try to trick you. There is nothing to it. So there is a bag which contains 10 red balls and 15 blue balls. Let's say we'll use B for blue balls and R for red balls. So two balls are drawn randomly without replacement. So when first ball is drawn, then total number of balls will be 10 plus 14, so 24. And then depending on whether red one was drawn or blue one was drawn, the rest of the things will be there. Now they're asking, given that the first ball drawn is red, what is the probability that the next ball is also red, so that both balls are red? I need to round it off to the 3 places. So one red ball is already drawn, right? So now you have 9 red balls in the bag plus 15 blue balls. So there are total how many balls? 15 plus 9. That is 24 balls, right? Now you need to pick one ball out of this and it should be red ball. And how many red balls are there? So 9 red balls are still remaining out of 24. And this is your answer. This will be 3 by 8. You can do the calculation and you should get 3 by 8. I think you can do that. Yeah, it's 0.375. Okay. Here they just tried to confuse students by giving this information that sometimes people assume then that this is a problem involving conditional probabilities and all. It's not. It was a straight simple problem, and this was question 63rd. So let's go to the next question. Yeah, so set 1 is over. Actually, there was like a couple of questions in set 1 which were interesting. And similarly, now we'll do the set 2 of the computer science and information technology GATE paper. Here, the weightage was slightly lesser. There were total 3 questions, 2 single mark and 1 double mark question. So you could have scored 6 marks if you knew the basic concepts that we are going to discuss. So this is question number 16, and it is it's use of what you call rule of definite integral, one property of definite integral. So let's go through the question. So there is a function f of x which is continuous function, and it is a real valued function which is given by this formula where f of x is equal to 1 minus f of 2 minus x. Now we need to find this definite integral where the limit is from 0 to 2, and you have to find the correct value of this integral. There are 4 options, one of them is correct. So now there is a special property of definite integral that you need to use here. So what it says is, if you have limits a to b and if you have a continuous function that is integrable in these limits, then that will be equal to f of a plus b minus x dx. This is the property of definite integrals, and I think you might have studied them in +2 or somewhere there. So by that logic, we put a equal to 0, b equal to 2, because those are the limits in our question. So then it becomes 0 to 2 f of x dx equal to 0 to 2 remains the same, f of 2 minus x. And in the question it is given that f of x is equal to 1 minus f of 2 minus x. So now you can replace any one of them. We'll replace this because we want f of x. So this is nothing but equal to 1 minus f of x, right? The whole bracket. So this becomes 0 to 2 integration of 1 minus 0 to 2 integration of f of dx. I am just expanding the bracket. And see, this is integration of f of dx, f of dx. So when this term comes to the LHS, it will be 2 times. So you'll have 2 times 0 to 2 f of dx equal to integration of 1 between 0 to 2. So that will be x, and x goes from 0 to 2. So basically 2, and therefore your integral will be equal to 1, and that is your answer. Okay. Otherwise, yeah. Otherwise, one way is you can assume some form of function f of x and you can solve it. But since we are short on time, maybe sometime later we'll discuss that. It's basically you need to find the function which satisfies this criteria, and there is a function which looks like a triangle that can satisfy this, and maybe later we can discuss somewhere else. So now next question, which is question number 18. So in this question it is mentioned that there are 6 unbiased dice. So dice is that we roll, right? One die is having 6 faces, named as 1 to 6, 1 to 6 numbers. But here 6 such dice are rolled simultaneously, and question is asking what is the probability of getting all distinct numbers, that is from 1 to 6. So now this type of questions, it is always helpful to just see how many combinations are there possible. So let's say there are 6 dice and we input the output of each die in one place here. So let's say if I throw first die and I get 1. So how many ways are there to get 1? Like, I mean, there are 6 digit sides. So I can get either 1, I can get 1, 2, 3, 4, 5, 6. So I can get all any number out of this, right? But if one of the number is here, then you can't get it here. And so if you know this number, then there are 5 options remaining and 5 numbers remaining. So you have to cut out that number. Let's say if you get 1 here, then you can only have 2, 3, 4, 5, 6 here, right? And like that. So if you have 2 here, then because we want to find the probability where all numbers are discrete, right? Or distinct. So like that. So there are how many ways we can fill such vacancies? The first place can be filled 6 times in 6 different ways. But second place can only be filled in 5 different ways because one number is out now, which we got in the first die. Similarly, one number will be kept on decreasing. So this is nothing but 6 factorial. So these are the total combinations possible. Then what is the total number of possible combinations? So now it includes all sorts of combinations. So there will be repetitions, no need for distinct cases. So now first die can have 6 outcomes, second can also have 6. So all dice will have 6 outcomes, right, independently. And that will be nothing but 6 to the power 6. So that is what we need to find out. So the probability of getting 6 distinct numbers is nothing but 6 factorial divided by 6 to the power 6. So if you expand this, you will get 5 into 4 into 6. 1 6 will be gone here, so 6 to the power 5, right? So 5 6s will be there. So one more will be gone from here. And then this 4 cancels and 1 9 will come here. So basically you have 5 into 36 into 9. So 5 by, so this will be 5 and 27 plus 5, 30, 32. So this will be 5 by 324. Yeah, so the option B is correct here. Yeah, this is your total combinations possible. Okay, so now we'll come to this question. This was also interesting question because here you need to use one correlation of this, what do you say, combined expectations. So let's go through the question. The question says it was a question number 44 of the set 2. So there are 2 random variables x and y, and they are not necessarily independent. So this is a very, very important information for solving this question, and you'll see how. That take real values between 0 to 1. Okay, so they are bounded in this region, and let z be there, which is function of x and y and their product basically. And mean values of x and x, y, z are x bar, y bar, z bar. So this mean value is nothing but expectation of these random variables. then it is asked that which of the following statement is true. So here you need to take a note that only one option is correct. So either it can be one option from these three, or it will be fourth. Correct? Because it's only single option correct, and A, B, C cannot be true together. Either A will be true and B and C will be false, or similar combination. Otherwise, if all of them are not true, then option D is the correct option, right? That is what the logic says. So now we need to use one identity of expectation of product of two random variables is nothing but expectation of random variable, first random variable, multiplied by the expectation of second random variable, then addition in addition to the covariance of those random variables. This is the property of random variables. Okay, so now we know that this covariance will be equal to 0 if x and y are independent. That is the definition, or by the definition you get that. But in this question it is mentioned that they are not necessarily independent. So uh, covariance of x and y, there are three possible combinations. It can be equal to 0, or it can be greater than equal to 0, or less than equal to 0. They have not given any information about that. So let's assume that it is 0. In that case, what happens? So this expectation of xy is nothing but your z bar, and this expectation of x is your x bar. Expectation of y is your y bar, plus covariance of x comma y. So I'll write it in a different slide here. So what do you have is z bar is x bar into y bar plus covariance of your x and y. And there are three options. It can be equal to 0, greater than, less than 0, or greater than 0. They are not, in the question it is not clear what should be the covariance of these variables. So if it is 0, if covariance is 0, then your z bar is x bar comma y bar. That is option A. Okay. But if it is less than 0, that is z bar is less than x bar comma y bar. Is option B. If it is greater than 0, z bar will be greater than x bar comma y bar. That is option C. So as I said, all of them can't be true. So none of them is true. If in the question, if it was mentioned that uh, these x and y random variables are independent, then option A was correct. Or if they would have mentioned that covariance is positive or they are positively correlated, something like that, then you can say that covariance is greater than 0 and option C is correct. But nothing of that sort is mentioned, so all of them are wrong. And by that logic, option D is correct. But you can see why option D is correct. So let's take your random variable, and it is given that uh, x and y belong to this 0 comma 1 range, right? It is given in the question. So you can write this 0 is less than or equal to y, less than or equal to 1. Now multiply by x on the both sides. So you will get 0 less than or equal to xy, less than or equal to x. But we know that x is also less than or equal to 1, right? Because that is the information given in the question. And therefore, what you can say is, sorry, this inequality holds. Now what you do, you take expectation of this inequality, and expectations preserve inequalities because it's a linear operator, and basically it is taking mean, right? So if you take uh, inequality mean, that is also correct. So therefore this expectation of 0 will be 0, expectation of x and y will be like this, and this will be expectation of sorry, it should be x here. This is fine only. So this will be expectation of x. So that is nothing but 0 z bar x bar, and therefore this option D is correct. It is also implying that z bar will be less than or equal to y bar, because you can, instead of multiplying, instead of taking y, I can take x and then multiply by y. So you'll have y here, and then you'll get this. So if this option was also there, then this is also correct, but it was not there. So only option D was there, correct. Okay, so yeah, I think this is the last question. This is question number 47, and it is mentioned that there is a matrix A, which is a square matrix. So determinant will be there, and it has set of all real numbers as its elements. Then there is a matrix B, which is a matrix obtained from A. B is obtained from A by swapping its two rows. Now, which of the following statements is or are? So this is also important. So it's a multiple choice question, and we need to find true sentences, not the false. So now it's even if you don't know any of these theorems about matrices and all, as long as you can take the determinant of a matrix, you should be able to solve this question. So what it means is, your first option A, says that determinant of B is negative of determinant of A. Is it correct or not? So see, that is the property of matrix. So if you know the property, that this option is correct by definition or by property of matrices. If you don't, you can just assume A matrix as an identity matrix. Let's say 0 1 0 0 0 0 1. Why identity matrix? Because it's simpler. The calculations become simple. Then you swap any two rows. Let's say I swap second and first. So this becomes 0 1 0 1 0 0 and 0 0. Third row remains same. If you do this, this is what the question is saying, right? And we know that determinant of identity matrix is 1. So you don't need to do the calculations here. So you'll get 1 as the determinant of A. And now you just calculate determinant of B. So what will be the determinant? It will be -1, because you can just do the calculation. So therefore option A is correct. So like this, you have to check every option. So now option B says, if A inverse exists, that means if A is invertible, B inverse also exists. This is the question. I am writing it in some different form, but in question it was asked that if A is invertible, whether B is also invertible or not. And see, for inverse, the necessary condition is determinant should exist. If determinant is there, then only one can find inverse of any matrix. And just now in option A, we proved that whatever is the determinant of A, uh, the determinant of B will be negative of that. So if A is invertible, that means determinant of A will be non-zero quantity, and then determinant of B will be a non-zero quantity also. It will be negative but non-zero. So therefore determinant of B will also exist. So if you can correlate it with the option A, the option B is correct. So then next option, if A is symmetric, B is also symmetric. Here only you can see, right? See, this is a symmetric matrix, matrix A. But when you swap two rows, does your matrix B symmetric? Is it symmetric? No, right? It's not symmetric matrix. Or in this case it is, but I can take another example, maybe just to prove my point. Let's say if A is 1 2 3 4 5 6 7 8 9, and then if I swap two rows, what it does is 2 5 8 1 2 3. One second. Yeah, A needs to be symmetric, right? So let's say this is also 2, 6 and 3. So now it's a symmetric matrix, right? Now you swap the rows. So now what it is? 2, 5, 6, 1, 2, 3, 3, 6, 9. So I have swapped first row and second row. Now, is it the symmetric matrix now? No, right? So, not symmetric. So, option C is wrong. Now, option D. So, option D says if trace of A is 0, if trace of A is 0, that implies trace of B also 0. What is trace of a matrix? It's a summation of its principal diagonal elements, right? So, in this case, we can take this same example which we took for option C. So what is the trace of option matrix A in option C? It is 1 plus 5 plus 9. So that is 1 plus 5 plus 9, that is 15. Whereas what is the trace of matrix B? It is 2 plus 2 plus 9. So that is 13. So they are not equal. So therefore option D is also not equal, not correct. So option A and B are correct, C and D are not correct. So that is regarding that. Yeah, I think we are done with the questions. So now this is the conclusion of this class. And if you are interested in similar courses for your GATE or any other competitive exam preparation, you can reach out on this number given here, uh, or you can drop a mail to this email ID mentioned here, or simply you can just go to this website and you can check out various offerings, and hopefully that will help in your exam preparations. And with that, I thank everyone, and yeah, you can check out all these social media handles also, and wherever you are comfortable, you can follow. That will definitely help in your exam preparation, is what I mean. And with that, this is the, I mean, this is the end of the class. So, uh, shall I stop, sir? Yeah, I think Dinesh sir is not here. In the meantime, I'll share the notes. Then we'll stop. Yeah, it is taking some time to share the slides, but yeah, it should be done. Yeah, so I've shared the notes also. So I think I can stop right